How pulse pressure is calculated? So the pulse pressure is calculated by the systolic pressure minus diastolic pressure. So 1 to mmHg minus, if the reading is 1 to systolic reading is 1 to 120 mmHg and the diastolic reading is 80 mmHg, though the value of pulse pressure will be 40 mmHg. So there is systolic pressure and diastolic pressure. Systolic pressure is due to the aortic pressure that during ventricular systole, and diastolic pressure lowest aortic pressure during ventricular diastole. So next is mean atrial pressure. So the mean atrial pressure or MAP is equal to diastolic pressure plus 1/3 pulse pressure. So there is mean arterial pressure, which is known as diastolic pressure, mean value of arterial pressure. So different pressure occurrence, different arterial pressure in a given time. So the mean value will be identified by diastolic pressure plus 1/3 pulse pressure. The pulse pressure is how we would identify. We'd identify pulse pressure by the systolic pressure minus diastolic pressure. That is pulse pressure. So if we want to find out the mean value of arterial pressure MAP, we need to add diastolic pressure dP plus 1/3 pp. So dP plus 1/3, 1/3 means the 1/3 value of the pulse pressure adding with the diastolic pressure. So diastolic pressure is arterial ventricular diastole low aortic pressure. So diastolic pressure is low aortic pressure. So what happens in low aortic pressure? The diastole is relaxed or the diastole is filled. In ventricular systole, the myocardial is myocardium is filled. Myocardial contraction is occurs, and diastole the myocardial relaxation occurs. So how to find the mean value of arterial pressure? We need to find the diastolic pressure plus 1/3 of pulse pressure. How we find pulse pressure? Systemic diastole minus systolic pressure minus diastolic pressure. Next is control of mean atrial pressure. So there is control of mean atrial pressure. Mean atrial means mean atrial pressure value. So we can find from the equation what we can find. There is diastolic pressure minus 1/3 of pulse pressure. So it is equal to mean value of the arterial pressure. So the PP is identified by pulse pressure is identified by systolic minus diastolic. We get the value. So it is 1/3 plus diastolic pressure. So the mean value is the addition of low arterial pressure plus systemic and 1/3 of systemic and diastolic pressure. That is the mean value. So next is we can see the pressure that propels blood to the tissue, maintains tissue perfusion. That is the arterial pressure. That is a pressure required for the blood to reaches the tissues. So this mean value of blood or the atrial pressure is very important for the blood to get perfused into the tissues. The tissue perfusion of blood is occurred due to this mean value of pressure. So we're going to study about how this mean value of pressure is controlled, or how this mean valuation get diverted, or how it regulates. So there are three main regulators. First one is the auto regulation, which is at tissue level. Auto means automatic, regulation means a change in system means regulation. So automatic regulation. So first control in mean value is automatic regulation or auto regulation. So it is seen at the tissue level. This automatic regulation is seen at the tissue level. So automatic vasodilation, or automatic constriction at the tissue relative to metabolic requirements. So at the tissue what happens? There is constriction of the automatic constriction or vasodilation occurs. For the according to the tissue's metabolic requirements, the tissue itself regulates its vasodilation and constriction. So that is how mean value pressure is maintained or regulated. Next is neural mechanism. In the neural mechanism, vasomotor centers means medulla. So there is vasomotor. So this motor help in vasodilation. So this medulla, this center in vasodilation center in medulla regulates the control of mean atrial pressure by the baroreceptor and the chemoreceptor. So the vasomotor centers in medulla control the regulation of atrial regulation is done by vasomotor by the baroreceptor, which decreases the pressure, and the chemoreceptor, which increases the pressure. How baroreceptor identify the pressure variance because there is receptor cells inside the atrial walls. So this receptor cell identify the pressure difference. So it reduces the pressure by inhibiting the atrial constriction. So this is how the baroreceptor work, and the chemoreceptor work by increasing the carbon dioxide. When the brain identify that the body needs more carbon dioxide or the pumping need more carbon dioxide, so it increases the respiration value and the heart rate. That's what chemoreceptor does. This both are known as vasomotors, and is seen in medulla. Not in medulla oblongata, in medulla. So next is autonomic nervous system. So there is vasomotor centers. Next is the autonomic nervous system. Autonomic nervous system, we studied about the autonomic. There is parasympathetic and sympathetic. So the sympathetic gives what? It increases the heart rate, it increases the contraction, it increases the MAP value. So the heart rate or the sympathetic system increases the mean atrial pressure by increasing the heart rate and increase the contraction. Next is the parasympathetic. Parasympathetic is simply the opposite of sympathetic. So it decreases the heart rate and it increases the mean atrial pressure. So that is the three regulation of atrial mean atrial value or mean atrial pressure. Next is the third one. So in neural mechanism there is 2 points, vasomotor centers and the autonomous center. So these both are from medulla, and those are in parasympathetic and sympathetic or the autonomous nervous system are controlled by medulla oblongata. So there is a neural mechanism is both seen in medulla and medulla oblongata. So the autoregulation is at tissue level. Next is the vasomotor centers are seen in medulla, control is seen in medulla. Next the autonomous nervous system is seen in medulla oblongata. So this is the neural mechanism. So the autoregulation is at tissue level, neural mechanism is at brain level, and next is the kidney level. So the third one, you can see the kidney level. It is the endocrine system. The kidney is the endocrine system, it's endocrine gland. So it is an endocrine mechanism of kidney level, at kidney level. So first point we can see antidiuretic hormone, which is also known as vasopressin. So vasopressin, this is very important, we studied in plus 1 and plus 2 classes. So the vasopressin, or also known as antidiuretic hormone, ADH, or vasopressin have the ability to water, the retention of water or the release of water from the kidney. So the release causes the pressure increase in MAP. So the retained water released, or the retention of water retention when released increases the mean atrial pressure. So the antidiuretic hormone, what is known as, it is known as vasopressin. It what happens, it water retention or the retention of water is when the retention of water is released, it increases the MAP or the mean atrial pressure. Next is the which angiotensin. Angiotensin second. So the first one is antidiuretic hormone or known as vasopressin. Next is angiotensin second. What happened in angio second? It help in vasoconstriction. It help in vasoconstriction. So what happened when the vessels constrict or the vasoconstriction occurs, or the MAP increases. Next is the erythropoietin. So we discussed about angiotensin. Next we discuss about erythropoietin. So the erythropoietin or the EPO has control over hematopoiesis, which is the increase of blood volume level in the arteries. So when there is increase of blood level in the arteries, the mean atrial pressure increases. So the erythropoietin does the hematopoiesis or the increase of blood volume. Thus it increases MAP. So we discuss. Now we are discussing in the endocrine mechanism. In endocrine mechanism, how many types are there? There is antidiuretic, meaning vasopressin. There is angiotensin second. There is erythropoietin. Next is natriuretic peptides. Natriuretic peptides, which is released by the heart. So the natriuretic peptides stretch on the heart. So the natriuretic, when the heart stretches, the natriuretic peptide is released. When the heart stretches, the natriuretic pressure or the natriuretic peptide release, and this causes diuresis. So it decreases the blood pressure and the volume. So what happens when the blood pressure and volume decreases? It has decreased level in MAP. So there is natriuretic peptide release in the heart when the heart is stretching. The natriuretic peptide release, and it causes diuresis. We have to remember it is in the heart, not in the kidney level. It stretches when the heart is stretched. It causes the increase in diuresis, and it reduces the BP and volume.